Okay, let's start with the most basic example. Um, it's basically just the formula. As you can see, it's some variable to the power of some constant. Here we have this in the integration table. It's just variable into the power of some constant. And yeah, so it's just from the table. We see it's 2 here, and for formula it's the power plus 1. So the power plus 1 is 2 plus 1, it's 3. And at the bottom it's we divide by the power plus 1, which is again 3. And this is the answer. But this table doesn't put the constants. Actually, it has to be like ln x plus c. So for each of this, it has to be plus c. So plus some constant. And you just have to put the constant here, any constant. The next example, a bit harder. Here, we look at this expression, and in opposed to the first example, we cannot just find the what to do with it from the table. It's not there. So we have to substitute. We have to first simplify this expression and then use the formulas from the table. So we will substitute this bottom expression, 1 plus 2x squared for u. And we need to differentiate now both parts. With respect to x, we just use implicit differentiation here. If you don't know how this expression become this expression, you probably don't know how to do implicit differentiation. So, but if you do, you just find dx from here. Then from here, it's just a proportion, and from here dx is just 1 over 4x du. And we use this to plug it in here. So instead of this dx, we use this expression. Instead of this, we use u here. Now we can just cancel out the x's, and we get this constant here. And if you have a constant inside the integral, you can just pull it out from the integral and like just put it before the integral. That's what I do here. So the same expression, just 1 over 4 is here, outside of the integral. And here we can just rewrite this thing for the sake of the formula to become obvious. We can write it like this, and here you can see again, as in the first example, it's just some variable into the power of some constant, which is a formula. We just use the formula, so it's minus 1 over 2 plus 1, just plus 1 over 2, and at the bottom, the same thing. We can cancel those out, and we get this expression. Just we simplify this one, and we get this, and we have to. This thing basically means that we have to plug in 2 there, and then subtract the same expression, but with 0 instead of this x there. That's what we do here. So we just take this expression. First we plug in 2 in there. We count it up. It will be 1 over 2 square root of 5. And minus this same expression, but with 0 here instead now. Here is it. This whole expression will be 1. So 1 over 2 multiplied by 1, it's 1 over 2. Here is the final answer. And as you can see, here the final answer is some number, like a constant. And which is different from here. Here we had an expression. Expression is that we have x here. So it's a function, because the integral was indefinite here. But here we have, because we have limits, our answer is a number. Okay, let's look at some trigonomic function. Here again, we cannot just plug it into the table, so we have to simplify everything first. We will substitute this 1 plus cosine square x for u. Here again, just implicit differentiation. Here, when you differentiate this expression, you will use the chain rule, so it's 2 cosine x, and now you differentiate cosine x, which is minus sinus x, and here is the sinus, and it's minus sign, so here's the minus. Yeah, don't forget the minus, we put it right here. That's the expression we get. So this we substitute with u, as we just done here, and dx we substitute with this expression. And if you remember from the trigonometry course, this 2 cosine x sinus x is just sinus 2x. We just will put it here. Now we can just cancel out those 2 sinus x's. So we cancel them out, and we get this expression. And now, if you look at the table again, you can see that it's right there. So now we can just use the formulas. It's minus ln u. In our case, it's u. And if you remember, for u, we've taken this expression. So now we substitute it back. And here is the final answer. Just yeah, instead of u, you just put this, what initially was taken as u. And you add constant, because the integral was indefinite.